So we're going to start looking at a bit more complex of our axioms. We're going to check if a single number exists in a row. Like we mentioned before, if this cell can be 8 or 9, if this cell can be 8 or 9, and this cell can be 5, 8 or 9, this cell has to be a 5. There's no other way it can exist. And here we are, we're going for our Sudoku. Let's say I is row, j is column, k equals like the back of the array, our options. We're going to go for I equals 1, so loop through the row. Now we're going to do k. So for k equals 1 to 9, or options, and for j equals cols. What we're going to do is we're going to take the first cell here, and we're going to start going from 0 to 9, from 1 to 9. We're like, hey, if you don't have a answer, stop. What I want to do now is I want to loop through, let's say 0, 0, 1 to 0, 0, 9. Sorry, to 0, 9, 9. I want to see how many times does 1 come up, how many times does 2 come up, how many times does 3 come up, how many times does 4 come up. Bit of a poorly drawn diagram, but you get the gist. And it's like, okay, if 1 only comes up 1 time, well, you must be correct. You couldn't exist any other place. I think the logic is correct, and I put a lot of couts to work out where I'm going right. I've done this a while ago, so this may not be the clearest explanation, but this does function based on the principle of if only one option exists in this row, by default you must be correct, assuming everything we've built before this is correct and working.